Okay. Okay. The reason why here they say it's chapter 11 is because the combination of STA1510 and STA1610. So those who are doing STA1510, this is chapter 10, the chi-square test. Now we have the key questions in this study unit here. One, how do you test hypothesis when population standard deviation is known? Two, how do you test hypothesis when population standard deviation is unknown? Three, how do you get a p-value? Then number four, what are steps to testing hypothesis in general? Okay, let us start now. 11.3 talks about the chi-square test for independence. So it means that when data involves two nominal variables with each variable having two or more categories. Now, a chi-square test for independent, it can be used to do what? To test whether or not there might be some relationship between what? Between the variables. Okay, now we have five steps, then we'll start with step one. We'll just highlight here. Step one here, we're talking about what? Step one, we do this. Okay, step one, you set the null and alternative hypothesis. You set what? The null and alternative hypothesis with step one here. That's step one. Now here, you all know that HO, we are talking about the null hypothesis. The null hypothesis, we are talking about the statement made about a population parameter to be tested. So here, because we are dealing with the chi-square test for independence, with the null hypothesis in this chapter, you don't have to say, oh, here I'm dealing with greater than, here I'm dealing with less than, here I'm dealing with two-sided. No, you don't have to do that. With this chapter here, just know that null hypothesis deals with independent variables. You see here they say the two categorical variables are what? Are independent. When they say that the two categorical variables are independent, it means that there's no relationship between what? Between them. That's this one is for null hypothesis. Just always remember this. Null hypothesis deals with what? Deals with variables that are independent, meaning that there is no relationship between them always. Okay, alternative hypothesis, the two categorical variables are dependent. It means that there is a relationship between them. Let's look at one question. I want to show you something. One question. Let me show you. Let's look at chapter 9, chapter 10. Let's look at. Now remember that null hypothesis, it deals with what? Null hypothesis deals with independent variables. It means that there is no relationship between two variables. Alternative hypothesis deals with what? Dependent variables. It means that there is a relationship between two variables. Okay, let's look at this question here. Yes, yeah, this one here. It's question 11. It is follow. The certain media company published 4 magazines for the teenage market. Now, the executive editor of the company would like to know whether readership preference for the 4 magazine is independent of gender. Now, a survey among 200 teenagers was carried out. Now, here they said the following contingency table. Contingency table, they're talking about this table here. We have gender, magazine preference. Okay, under gender, we have girls, we have boys. By looking at this question here, you can see that this one is based on the chi-square test independence. By what? By here. They say the chi-square curve is symmetrical. Let us now focus on option 2 and option 3. On option 2, they say the null hypothesis HO is gender and magazine preference are independent. Remember, when you are dealing with null hypothesis, you are dealing with what? Null hypothesis, you are dealing with two variables that are independent. When they say they are independent, it means that there is no relationship between two variables. Always remember that. Then with alternative hypothesis, this one here, alternative hypothesis is gender and magazine preference are dependent. When they say that they are dependent, it means that there is a relationship between two variables. You see now, already now you see that option 2 and 3, correct. You see, always remember that. Remember in this chapter, you are not going to use that method of, oh, it's less than, oh, it's greater than. No, I think this one is maybe not equal to. No, you are not going to. That one is for chapter 9. That one is for chapter 9. Here you are dealing with independent, dependent relationship. There's no relationship. There's a relationship between two variables. Hope you all understand. Any question before we move to step 2?
No, no question.
You all understand?
Yes.
Oh, that's great. Oh, let's know. Can you please mute your mic? Thank you. Okay, step 2, you determine the test statistic. Step 2, you determine what? The test statistic. So here when they say you determine the test statistic, they are talking about the test statistic of the chi-square. By using which formula? This formula here. X squared stat is equal to the summation of all cells, open bracket, FO. FO, they are talking about what? They are talking about the observed frequency. I will explain this one when you do your calculations. Always given. You see, always this one, always given. FE, we are talking about expected frequency. Can you please mute yourself? Expected frequency. FO, they are talking about expected frequency. Guys, if you don't mute yourself, then it means that I'm going to remove you from our session. Remember, you will unmute yourself if you don't, if maybe you want to ask a question, or maybe if maybe you want clarity. Okay, so here FE is the expected frequency. The expected frequency is calculated from by using this formula. Remember, FE, we are talking about expected frequency as FE, talking about expected frequency. Then FO here, we are talking about observed frequency. Okay, let's now calculate the test statistic. Let's calculate the test statistic. Okay. Okay, here it's question 1 here. Question 1. So let us look at question 1 here. I think question 1 we are required to calculate the test statistic. Question 1. Okay, question 1 we are required to calculate test statistic. So when looking when looking at question 1 here, it is for some students decided to test the assertion that one cannot tell the difference between butter and particular brand of margarine. They recorded their result as follows. We have male, we have female, then here under column we have could tell, then here it's could not tell. Now to test if there is any significant difference between the ability of males and females in distinguishing between butter and margarine, the test statistic you see now, they say what? The test statistic is equal to, remember the formula. The formula, we are going to use this formula here. But before you would calculate the test statistic, firstly, you must calculate what we call the expected frequency. You see this FE, it's expected frequency. Very simple, interesting. By saying row total multiplied by column total, you say, okay, now when we look at this question here, you can all see that we have male, okay, we have female, we have the column total could tell, then could not tell. When you look at this question, we don't have the two charts. It's like when we are dealing with chapter 4, the probability, basic probability. When you are given a continuous table and when you are not given the sorry about that. When you are not given the two charts, firstly you know that you have to go with the two charts. So even even with this one, we're going to add column here for the two charts here. The two charts here. Okay, here the two charts. Okay, it's like this, it's like this. Okay, and then again here we're going to add another row total here. Total. Okay, total here. Okay, then here we're going to add column total here, column total here. Then it's like this. Okay. Okay, yeah, it's like this. Now we say 16 plus 21. 16 plus 21 should give us 37. That's our column total. which will give us 37. This one here. Then now we say 14 plus 9. 14 plus 9, which will give us 23. Which will give us 23. 23. Now here we have another total here in this total here, total here, total here. So we say 16 plus 14, which will give you 30 here. So here it's 30. It's 30. Then again we say what? Then again we say 21 plus 9, which will give us 30 again. Here 30. 30 here. Now we can just say 30 plus 30. That's our sample size. That's our sample size or random sample, meaning that n is equal to 60. N is equal to 60. N is equal to 60. Now we have our two channels now. Now we can calculate what we call expected frequency. FO, remember FO is observed here. FO it's the observed frequency, always given. Then FE is expected frequency. You're going to use this formula here to calculate expected frequency. Okay, now here, let's look at this question. We are required to calculate the test statistic. Okay, now I'm going to show the formula. Okay, you see here, we are going to start by doing this, by using this method here. Going to start by using this method to calculate FE. So here, they are showing you that here, they started with 14 for expected frequency for 14. I agree here it's row total multiplied by column total divided by sample size. And now we all know that sample size is equal to 60. Now pay attention to this one here. This one is very easy. It's very easy. Let me show you something here. You see now, let us start now. Let me show you something. Remember, we start by calculating what? We start by calculating expected frequency by using which formula? Expected frequency is equal to row total multiplied by column total. When you look at this part here, it's our what? This part here is what? Our column total. This part here. This one is our column total here. This one here, under male and female, it's row total. Please remember that it's row total. Then this one here, it's column total for could not tell, column total for could not tell. Then this one here, it's row total for male, row total for female. Okay, hope you all understand that. Let me do this here. Let me do this here. Hope you all understand that. Okay, now let's do this. Now we substitute. Now we want to do what? We want to calculate the expected frequency. FE is equal to what? FE is equal to row total. What's our row total? This one here. 30. Can all see 30. Then we say what? Then we say 30 multiplied by what's our column total? Here's our column total here. Remember, these are your columns. Multiply by 37. 37. I cannot see this properly. 37 here. Okay, let me do this. Multiply by 37. We divide by what? The sample size. Our sample size is equal to 60. Okay, let me wait. Okay, sorry, what's happening? Oh, yeah. Our sample size is equal to 37. Our sample size is equal to 37. So here now we say multiply by 37 because our column total is equal to 37. Then 37 divided by 60. Divided by 60. Then you get your answer. Then now we move to this one here. We say now FE is equal to what? Row total. FE is equal to row total. What's our row total? Row total is this one, 30 again. We say 30, then multiply by what? 30 multiplied by 23. 23 is our column total here. 23 is our column total. 23 is our column total multiplied by 23. So here, 23, then you divide it by what? Divided by 60. Divided by 60 here. Then you get your answer. Now we move to this one here. When we move to this one, then we say FE again. FE, remember it's what? FE is what? FE is what? Expected frequency. Expected frequency then is equal to, remember our column total, our row total by using this formula. Remember this formula, row total. Row total is what? Row total here for female is 30. Then we say 30 multiplied by what? Multiplied by column total is what? Column total is 37. Multiplied by 37 here. Then divided by 60. Then you get your answer for this one. Then now you move to this one here. You're just going to do like that. Is equal to row total, this one. Remember, now we are under female. Row total, this one here, we say what? 30. 30 divided by, multiply by column total, 23, which is 23. Then multiply by 60 here. 6, then you get your answer. Let me show you. Then you get your answer. Here it is. You see, get this one here for 16. Then they get this one here for 14. Then they get this one here for 21. Then they get this one here. Then after calculating your expected frequency, you can now calculate what? You can now calculate your test statistic. Here it is. You see, for this one, we got 18.5 as our expected frequency. For this one, we got 11.5 as our expected frequency. For this one, we got 11.5. For this one, we got 18.5. How do you get those like values here? I've showed you here. See here. Where is it? Here, you see. Here, by using this method. Then now we can substitute and calculate the test statistic. Now you see here, we'll say 16 minus open bracket. You should just do like this. Open bracket, you say 16 minus 18.5, then you square. Then you say plus. You see, plus, then open bracket, 14 minus 11.5, open bracket, then squared. You see, then after then you say plus here. Then plus what? 21, open bracket, then close bracket, then squared. Then plus 9, then open bracket, 9 minus 11.5, close bracket, squared. That's what they did here, you see, squared. Then you divide it by what? I forgot. Then here you divide by 18.5, here 11.5. Then here you divide by 18.5, then here it's 11.5. Remember with this chapter, it's very short. Please pay attention. Please pay attention to this one, because here you can just get like good marks, like full. This one here. Then that's what they did here. Then at the end, they got 1,76 as their final answer for the test statistic. Here's the formula of the test statistic. X squared state test statistic for the chi-square test. Or you are meeting will end in 10 minutes. Okay, meet. Any question?
No question. This is the one that you sent us last night on WhatsApp, ne?
Yes.
Because we did this yesterday on WhatsApp.
Okay. Okay, now let's move to step 3. Remember step 1, you do what? Step 1, you set the null and alternative hypothesis. Step 2, calculate the test statistic. Then let's now move to step 3. Step 3. Okay. Okay, step 3, is it?